Now, let's take a quick look at MFI. Are you ready? Let's go. What is MFI? MFI is Melt Flow Index. It's a flow test used to assess material degradation due to molding stress. In every molding process, the material gets heated, melted, rotated, squeezed, and pushed. All of these stresses makes the material break down a little bit. The breakdown is referred to as material degradation. When a material gets stressed and degraded, several things happen to the performance. Two of the main breakdowns are mechanical performance suffers, and there's a splitting of components that happens. Let's talk a little more about that. Degraded material will have lower mechanical properties. It may perform badly in drop testing, functional testing, and environmental testing. Sometimes the molded stress on the material forces it to separate into its component parts. Typical ingredients in plastic resins include the raw resin, pigments, plasticizers, flame retardants, and lubricants. For example, if the pigment or the coloration separates during molding, then you can get all sorts of weird cosmetic defects. Simply put, it's good to keep material degradation to a controllable minimum. Again, every molding process stresses and degrades the material, every one. The key is to manage the part design, the tool design, the process, and the material selection to make functional and beautiful parts. MFI is used to measure and monitor this degradation. It measures the percentage change in flow before molding versus after molding. So it measures the flow rate of the resin pellets versus the flow rate of the plastic in the molded part. The MFI test shows either an increase or a decrease in flow rate, and this equates to a percentage difference. Some materials flow more when degraded and others flow less. The test shows either an increase or a decrease in flow rate, hence the percentage units. Where and how is MFI testing done? Well, it's usually done at the molding vendor facility. Flow is tested again using a rheometer, and this is the same device as we use for MFR. To get a better feel for the whole process, let's take an imaginary trip down to the molding shop and walk through the testing process from start to finish. How's that sound? Okay, let's go. So again, as a quick recap, MFI is the comparison of material before molding versus after molding. That means we need to get test samples of the before and after. Samples are taken from the neck of the hopper. 3 samples are usually collected, and these samples are then stored in sealed containers for testing. So what happens after molding? We take the plastic part and we cut away some material from the plastic part. This sample plastic is then chopped into pellet-sized bits. 3 samples are produced, and again, these samples are stored in sealed containers for testing. Both sets of samples are taken to the on-site test lab. Here's a condensed sequence of what happens. We test the 3 before samples and we calculate the average value. Then we test the 3 after samples and again calculate the average value. We check the difference between the before and after values, and this gives us a percentage difference. The general target is to try to keep MFI below 30%. If the difference is 30% or higher, then this triggers a debug process to lower the MFI. Lowering MFI is a whole other story. I will develop this in a future video. So there you have it. You now know that MFR and MFI are kind of different, and you know how and why. So give yourself a pat on the back. Well done. Thank you, and bye for now.